Hi my dear friends, welcome back to our render setup workshop. My name is Hussein Mashayikhi. And in this session we're going to focus on the method of light cache for our rendering engine. Okay, so we had the primary engine and the secondary engine. We talked about it in detail in the previous sessions. We had array of light that comes into our scene from somewhere, let's say this one, and we had the first bounce or the primary bounce in green like this, and we also had some bounces after that. Okay, so the primary engine used to take care of the first one, the first bounce, and the secondary engine takes care of the calculations for all the subsequent bounces. Okay, so today, for now, I select light cache for both engines. Let's go down. We have also a preset here that we can choose. We have still and animation. Obviously, a still is used for one frame. So if you want to have an image like this, a render image, we use still, and if you want to have some kind of animation, then we would need to use the animation preset here, and that way we would have a number of frames put together. Okay, so we want to have one frame and one image, so I'm going to put it on a still. And next we have subdivs, which is like the subdivisions or the number of samples that we want to collect for our light cache method, kind of similar to the irradiance map with the sample collection. And here we can determine the number of samples that we want. So both engines are using light cache, and as you can see, if I take a render, it's not that good of a render. You know, the quality is very low, and that's why we never use light cache as our primary engine. We solely use it for the secondary engine sometimes. And as I previously mentioned, the light cache method is not good for calculating the first bounce or the primary bounces. Okay, so we never use it for our primary engine. Let me change the number of subdivisions. I'm going to choose a lower number, like 10. And the results are going to be even worse. Okay, so you can see how bad the render looks for yourself. And as I said it before, I cannot emphasize this enough, we never use light cache for our primary engine, and if need be, we only use it for our secondary engine. So if I change this number to 1, the number of subdivisions, the results will be even more terrible, as you can see. And now I think that you got a pretty good idea of how subdivisions or the number of subdivisions corresponds or works with light cache. So if I put 200 here, it's going to take a longer time to finish the render, and the overall quality will be better. So if I change this even to a bigger number like 2000, let's say, the quality will be even higher and it's going to take even longer, but still not that good of a quality to be using light cache for our primary engine. Okay, so let me just wait for it a little bit more, and then I'm going to cancel the render, and you can see how the quality improved with a higher value for our subdivisions. Okay, so we are getting a slightly better quality render here, but it's still not, you know, anything that is acceptable for the standards of our work. Alright, so we just witnessed what this number could do for us. The bigger the number, the better the quality, but also the longer it takes for the render to finish. If I put it on 1, you can see that it just instantly finishes the render, but the quality is trash. Oh, and by the way, I'm right now using an Intel Core i7 laptop for these demonstrations. I do have a very powerful personal computer with high specs and everything, but I wanted to use a mid-tier laptop so that, you know, it would be similar to a laptop that some of you might use. Okay. Alright, so let's just talk about something else. Before that, I'm going to change the number of subdivisions to 10, and I'm going to take a render. And after the render is finished, we're going to be talking about the sample size. Okay, so we just talked about the number of samples that we want to be collected using the light cache method. This other option, sample size, gives us control over the size of the sample that we want to collect from the scene. So the bigger the number, the lower the quality. So if I change this to 10 and take a render, you can see that the quality of our render has decreased greatly. So we gotta use a relatively small number for the sample size. Okay, so if I change this number to, for example, let's say 20, twice that number, it's gonna be even a lesser quality. Okay, but beyond a certain number it won't be that noticeable. So let me just go back and change this number to a low value like 0.001, let's say. And if I take another render, it's I think it's just too small. Let me just change it to 0.01 and see, we are getting a slightly better quality compared to when the sample size was 10 or 20. So overall, the rule of the thumb regarding sample size is that you should use a very low value, but not too low, because that would be problematic as well. So let me just put primary engine on radiance map again, and I'm going to change this to default, and I'm going to use the subdivisions of 10 and also sample size of 0.01, and I'm going to take a render, and we're going to start talking about something else. So let me just quickly delete the previous renders here in our history, and I also want you to take note of the amount of time it takes for this render to finish, and then we're going to be talking about the quality. Alright, so for this render we are using radiance map for primary engine, light cache for secondary engine. We have 10 subdivisions, and we also using the sample size of 0.01. Alright, so let's just wait for this to finish. It's finished now. It took 57 seconds. Alright, let's take another render, this time with let's say a bigger number, maybe 2000 subdivisions. Okay, so I'm going to keep the other details the same, the rest of the setting is the same. So let's just wait for this one to finish as well. Alright, it's finished. It took 1 minute and 9 seconds, and we have two different renders. The one on the right is using 2000 samples or subdivisions, and the one on the left is using only 10. And if we compare the differences are just negligible. You know, honestly, we cannot see that much difference between the two renders, and as you can see, it's just the differences are just in some places not noticeable at all. All right, so what does this mean? This means that sometimes even if we are using a really big number for our subdivisions, it doesn't matter that much. So let me change the sample size. I'm going to make it 1/10 of what it was. I'm going to add a 0 to it, so it's 0.001. Let's see what this one looks like. So this one took 1 minute and 15 seconds, and let's just compare it. It's going to be on the left, so let's just compare it with the other one. Again, not that much of a difference, and I always compare the features of V-Ray with Corona, and while Corona is making everything more simple and less complicated, and it gets rid of some of the setting, V-Ray insists on keeping these settings for us to manipulate, but sometimes we don't need to, so I'm going to keep it at 0.01. That's a good number because we didn't really see that much of a difference with a smaller sample size. And let's just move on to another option here. So we also have this option here called retrace, and what it does in simple terms is that it just calculates the GI in the corners or more complicated areas of our scene more accurately. So basically that's what it does, and I'm going to show you how it affects our renders in a second, but generally it's used mostly in animation. So if you want to have a more accurate calculation for complicated areas or corners in your scene, you can just use retracing for that. And make sure not to use a very big number, use a number between 2 and 6. And in a couple of seconds I'm going to take two more renders, one without retracing at all and another one with retracing enabled, and a value of 5 for example, and I'm going to show you the results so that you can just see the differences yourself. Oh, and by the way, the scene that we are taking renders from is not that complicated of a scene. We don't have that much of a detail, we don't have that many colors in it, so take that into account as well. So let's see how long the first render is going to take without retracing and compare it to the next one. Okay, so this one seems to be ready. All right, let's double check. So in this one we didn't have retracing enabled. It took 1 minute and 9 seconds. Let's just enable retracing and put a value of 5, let's say. Take another render and compare it to this one. And in the meantime, like I said before, V-Ray refuses to get rid of some of these options, make them obsolete, because frankly, these features do not, add anything to our scene, and they don't really change anything. So it kind of differs from what Corona in terms of being a direct competitor in this area. And it just goes back to the policies. Maybe they want to have more features here in the render setup, and that just helps with the marketing of the newer versions. Alright, so this render got finished as well. It took 1 minute and 12 seconds, slightly longer. Let's just compare A and B. So the one on the left is the one with retracing of 5, and the one on the right is not using retracing at all. Again, the differences are negligible, and we don't really see that much of a difference in terms of quality or anything else. Okay, so that's it for retracing here. We didn't see much of a difference. It just took a little bit longer. So we're gonna go back to our render setup window, and I'm gonna put back the value of 2 for retracing and leave it be. And we don't really have any other features to talk about here. And the last thing that I want to say here is that if you wanted to revert all the setting back to what it was for vray, all you have to do is to just go to renderer and momentarily change it to another option like a scanline, and again change it to vray. Everything will reset for vray. Okay, so let's choose radiance map for primary engine, light cache for secondary, choose very low for my preset, and I'm going to put this on progressive, and I'm going to take a render with this setting. So irradiance map as our primary engine, light cache as the secondary engine, and I'm going to take a render with this setting. I'm going to let it finish. I'm going to fast forward the video, and I'm going to take another render with brute force as my primary engine and light cache as the secondary one, and I'm going to show you the differences so that it would just save you time and help you when you are trying to combine light cache with either brute force or irradiance map. Alright, so I think the wait should be over right about now. It took 41 minutes and 54 seconds, and the quality is rather acceptable. It's a nice enough quality for us. And so this was irradiance map and light cache. Let's go back to render setup. This time I'm going to use brute force and also brute force for secondary engine as well. You know what? Because light cache and brute force are kind of similar when it comes to the secondary engine, so I'm going to leave it there. And then I'm not going to change the noise threshold, the same setting for everything, and also the same size or dimensions. It's around 800, and if you remember in the previous sessions I told you that for test renders that's a good number under 1000, and if you wanted to take a final render, use a size of 2000 maybe. And obviously if you use a bigger size like 2000, it would take a lot longer. Alright, so let's just wait for the second one to finish as well. It just got finished, 1 hour and 53 minutes for the brute force method. And if you want to start comparing these two renders, the time it took is a lot longer. And by the way, this is a fairly simple scene. If it was a more complicated one, I think the gap would be even greater than what it is. So for bigger projects, you can expect 2 or 3 times the time that it takes for irradiance map. And let's just compare them. The one on the left is brute force, on the right is irradiance map, and you can see that again the differences are not that noticeable, and in some areas the differences are very, very little. And that's because we don't have that much detail in this scene. For example, if you look at this plant here, with the brute force render, we have better shadows because it has done better calculations in those areas. But if we go to an area in our scene when there is not that much detail, you can see that, the differences are again very negligible. So the conclusion that we can make here is that the difference between brute force and irradiance map is only visible if we have enough details in our scene. Alright, so that's it for this session. I tried to take as many renders as I could to show you the differences using different methods, and I hope that that was beneficial for you. Let me just quickly show you what I'm working with. I have a 10th generation CPU, a Core i7 CPU. I have 16 gigabytes of RAM, and let me just show you my GPU as well. For that I need to go to device manager, and it's got to be here, display adapters. So it's a GTX 1650. It's a mid-tier laptop, and I've already provided this scene for you, this exact scene for this session, so you can just download it and using your own PC or laptop take the same renders, the 2 last renders that we took, one with irradiance map and light cache, and another one with brute force and also brute force or light cache as the secondary engine, and see how long it takes for you. And you can just use the same dimensions that I use. For example, 800 in 800 would be a good enough size, and you can just further compare the two methods yourself. Alright, so we are done with the GI section of our videos, and in the next few couple of sessions we're going to be talking about these other tabs here, image sampler, and the options or features that we have there. So that's it for this session. I hope that you enjoyed it, and I will see you in the next one.